right, guys. So this is part two, or part B of the mock that we did earlier. I've put the link of part A already in the description. Um, all right, so let's get started here. We are given again 40 minutes, 12 questions. That's what will be expected from you. And this is a calc active question, by the way. Graphing calculator is allowed. All right, let's try the first question. Okay. It's given over here that a figure shows a swimming pool filled with water, and the pump is used to remove water from the pool until the pool is empty. When the pump is running, the rate at which the volume of water in the pool decreases is constant. Okay, all right. So the rate at which the volume is decreasing is constant. All right. During the first 2 hours, the pump works slower than usual due to a broken pipe. Then the pump stops working. Then the broken pipe is replaced and the pump works at a usual rate until the pool is completely emptied. The entire process of emptying the pool takes 6 hours, and which of the following graphs could depict the situation where y is the water volume and x-axis is the time. All right, okay. I think over here it's more about just understanding the data and then matching it up with the graph. So I know that for 2 hours the pump was not working, right? Sorry, yeah, during the first 2 hours, and where was that? During the first 2 hours, the pump then the pump stops working, right? Pump stops working. I know that pump stops working somewhere, so that should depend. That should depict a horizontal line. And we know that here, since the pipe was broken, it works at a slower rate. So later on, when it started working at its full capacity, this should be more steep, right? This portion. So if this portion is more steep, it definitely means that this slope should be, obviously more than the previous one, right? I also know that it worked for 2 hours initially, and total it worked for uh, 6 hours. Okay, this clearly doesn't make sense because for this one and this one, if I compare, it's actually the other way around. Uh, it's not steeper. Rather, the first one is steep. That doesn't make sense. Here, both looks equally steep, so I'm gonna rule out C as well. Um, Between D and B. Now, in D, if you notice that the pump was not working for 1 hour, but if you see this initial condition says that the pump worked for 4 hours, which is absolutely wrong because they clearly stated that the pump worked only for 2 hours, right? So I think B is the only choice left, which also makes sense because the pump worked for 2 hours, then it went horizontal, so not working, and then it is more steep. So I'm going to mark option B as the correct answer. All right. The next question says that in a certain simulation, the population of a bacteria colony can be modeled using a geometric sequence, where the first day of the simulation is day one. The population on day four was 4,000 bacteria, and on day 8 was 49,000 bacteria. What was the population of the colony on day 6 based on the simulation? All right, so this is more of the geometric sequence case, where we know that it is given by an is equal to a1 times r raised to n minus 1, right? That's the formula that we are following. So for that, I'm just gonna say that for a4, I'm gonna say that a1 times r to the n minus 1, and n minus 1 will just be 3, and a4 is 4,000. So 4,000 will be equal to a1 r cube. That's the first situation. And likewise, I'm going to say that a8 is also given to us. A8 is a1 times r to the 8 minus 1, that is 7. And a8 is 49,000. So 49,000 is equal to a1 r to the 7. If I want to simplify this, because I need the population on day 6, so basically I need the value of a1 and r both. So what I'm going to say is I'm just going to divide both of them. I think that would make sense. So I'm going to divide for, although calculator is allowed, so you can also use TID4 or decimals because it's hybrid this time. But yeah, 49,000 over 4,000 will be equal to A1R to the 7 over A1R cube. These two are gone. 0, 0, 0, 0, 0, 0 is gone. So I'm left with 49 over 4, which is R to the 4. So from here, I got the value of R as 49 over 4 raised to 1 over 4. Let me just quickly find the approximate value of this. 1.87, about 1.87. So this is the value of R. I need A1 as well. So I'm going to sub that in an equation of your choice, maybe in the orange one. So this is going to look like 4,000 is equal to 1.87 times R. Sorry, we're not looking for A1. A1 times 1.87 cube. What is 1.87 cube? That's a gross number, which is 4,000 is equal to A1 times 6.5479 something. And if I divide 4,000 over this value, I'm going to get A1 as 610.8828. Okay, I'm looking for the population on day 6. So when n is 6, right? So I'm just going to sub that in over here. And this is going to look like A6 will be equal to A1 times R to the 6 minus 1. 6 minus 1 is what? Just 5, right? So I'm going to say that the answer is 610.8828 times R to the 5, where R is 1.87 to the 5. And if I do that, I have 1.87 to the 5. That's coming as 13969 something. I think the best choice will be C because that's the closest match. So that's how we do this question. All right, let's move ahead to the next one. Okay, they're saying that the rate at which the people entering a subway car on a particular day is modeled by a function R, where R is this and T is between 0 and 20. R is measured in people per hour and T is measured in hours since the subway began service for the day. Based on the model, at what value of T does the rate of people entering the subway car change from increasing to decreasing? Okay, rate of the people entering the subway car. What is that? That is basically the same thing as given to us, right? Because this is people per hour, and they are looking for when is the rate at which the people entering the car, right? And that's already given in the question to us as R. So basically, we just have to graph R and see where it changes from increasing to decreasing, correct? Isn't that uh, what they are saying? So let's try graphing this on decimals. All right, I'm gonna type this in decimals and see how it looks like. So it's 0.03. I'm just gonna replace t with x, so x cubed minus 0.8 46x squared plus 6.587x plus 1.428. And also I have to make sure that this is only between 0 and 20. I'm going to place a curly brackets here and 0, x and 20. Obviously that's greater than equal to, so maybe I'll press an equal to here as well. All right, so this is how the curve looks like. A pretty nice curve here, taking some turns and all. Okay, but what we are interested in is where it changes from increasing to decreasing, right? So increasing to decreasing means, don't you think that is the point? That is going right from increasing. Obviously, you see the curve to be increasing in nature till this point, and then it is decreasing, and this is exactly opposite, decreasing to increasing. So I'm going to mark 5.5 as my answer. Is that in the option? Yes, it is indeed. So 5.5 over here is the answer over here. Okay, I'm going to take a pause here. I think there's a question over in the chat. So I have a question. For a question like this, would it be better to use A1 is equal to R or G? Are they the same? Because we were taught the second equation, would it be the same? Yes, they are actually, I won't say these are same, but they serve the similar purpose. And yes, I do have students in my tutoring. They also ask me the same question. that in which case would the first one be better and the second case and the second one be better. If you just ask about question number 77 that we just did, I believe the second one that your teacher told you, G naught R to the n minus k, I think that will give you a faster result. But I personally am not a big fan of memorizing two different formulas, because sometimes the one that I used will give you a better result, or better as in fast result, right? That's what I meant. So it's up to you. If you are good in memorizing both and you know in which situations the other one will give you a fast result, feel free. I can give you a hint that, or maybe a situation that whenever they talk about something like, day 4 and day 6 is given and or day 4 and day 8 is given and then you're finding day 6, then yes, the other equation will make more sense. That will save your time, right? But I just honestly, I've just memorized this and I just use this and take the ratios and all. It works well for me, but yeah, it's a fair question and I hope that answers your question. All right, let's talk about the next one here. I think I'm talking about the regression model. Let me plug in the charger real quick. hmm Okay, all right, all set. The table below gives the value of m at selected values of t, and which of the following graphs could represent these data in a semi-log plot where the vertical axis is logarithmically scaled. Okay, I know that if the vertical axis is logarithmically scaled, it has to be a linear, provided this is exponential, right? I'm assuming that has to be exponential, because honestly, that's the type of questions we have been seeing. But yeah, of course, I can definitely take a quick ratio and see how it works. So 50 over 30 is, first I noticed that t values are increasing with the same with the same interval, which it is. So I'm just going to take the y values ratio. So 50 over 30 is just 5 over 3. The next is 83 over 50. The next is 39 over 83. And the next is 231 over 139. So what is 5 over 3, guys? That's 1.67 around. What is 83 over 50, guys? That's 1.66 exact number. What is 139 after, sorry, divided by 83? That's about 1.67. I think you understand what I mean from here, right? That's following the same pattern, about 1.66. Obviously, not an exact exponential function, but very close, because this is the actual data. And if you're going to model a regression, it is definitely going to be exponential in nature. So I know it has to be, whenever we graph a semi-log plot of an exponential function, it becomes a linear. It has to be a linear. So it cannot be A, it cannot be D right off the bat. Now only two linear things are remaining. And literally you can just take any point and plot it and see how it works. For example, 1 comma 30. 1 comma 30 is actually this the way how it looks. You just plot it the way we see it. I'm getting a feeling that it has to be C, because B doesn't really have those horizontal teeny tiny lines so that I can find out what's happening. But for example, 1 comma 30, 1 is obviously, I don't need to explain, 1 is just 1, and 30 is right here because this is 10. So the way we read the semi-log plot is, if this is 10, this is 20, this is 30, 40, 50, and so on and so forth. So clearly 1 comma 30 is placed very nicely. That's absolutely correct. So it has to be option C over here. So C works pretty well for this. All right. Yeah. I mean, you don't, unfortunately, yes, you don't really get any formula sheet. First case, second case, well, you have to decide based on the situation. But yeah, that's how it is. But yes, for arithmetic, since you asked this question, I just wanted to make this point that sometimes in arithmetic also arithmetic sequence, we see this question. In arithmetic, I think you guys know, and your teacher must have explained this already, that the common difference you can easily find by, the basically the difference between the two terms right away. Let's say I'm given an and I'm given am. So my common difference will be am minus an over m minus n. But this is only applicable for arithmetic sequence, right? Arithmetic sequence, which is obviously a little bit simpler in calculation compared to geometry. My teacher said there may be about 2 questions or so. Well, I do not know, but definitely there could be a couple of questions based on, well, whatever information I have so far. How important is semi-log plot for the exam? I think, yes, it is important because that's an exclusive thing that is only in AP Precalculus, right? A regular Precalculus course or um, uh, uh, Precalculus honors as well. They don't have semi-log. So what separates AP Precalculus is probably one of the topic is semi-log plot. So definitely that is important. Um, Not sure about FRQs. I don't think so. You can get FRQ, although not sure. But yeah, MCQs definitely. Expect MCQ on semi-log plot. So yeah. All right. Okay. All right. Question number 80. At a coastal city, the height of the tide in feet is modeled by the function h defined by this. Based on the model, which of the following is true? Pretty straightforward question, guys. They are just saying that what is the maximum and minimum value, and I can just give you a generalized way to solve this, whether that's a sine or cosine model. If it's a sine b times x plus c plus d, or if it's a cos b times x plus c plus d, it doesn't really matter what the model is. It should be sinusoidal in nature. Sinusoidal means that it should be either a sine curve or a cosine curve. Then the maximum value of these guys would be absolute value of a plus d, and the minimum value has to be negative absolute value of a plus d. So that's something that's gonna work every time. You can memorize that, and that's gonna solve the problem. So they are saying what is the maximum height? Obviously, the maximum height is just going to be the sum of these two. This is 6.3 and 7.5 added. So this is 8 and this is 13. Well, is A just the correct option? Is it that easy? I think so. Have I made a mistake anywhere? No, I think that is right. If you feel I've made a mistake, just let me know in the chat. But I think A is right. Yeah, A is definitely right. All right. Um, there are some steady tips they're asking. Well, I'm not sure if you're self-preparing or not. If you are not, then I think you should be getting some relevant stuff from your school as well in the form of worksheets. But if you need extra resources, I think my website has a page. It has a lot of, topic-wise worksheets along with video solutions attached, so you can refer that. Recently, I also added some ladders for FRQ types as well, FRQ 1, 2, 3, and 4. You can refer that. Another Unit 3 mock that I did a couple of weeks ago, the live streaming, I think I recorded that and it's also over there. You can also download a cheat sheet. I'll just put this is the link that I'm talking about. So you can visit this. You can download all the material, honestly, whatever you find relevant. And the cheat sheet is something that I myself created, so you may not find that anywhere. But yeah, of course, feedback is welcome. All right. Question number 81. Over here, we are given that the function is defined by this and this. And these are the 2 points represent the minimum and maximum respectively on the graph. And what are the values of A and D? All right. Again, it's a formula-oriented question. For this, I can definitely just give you the formula that we have. The absolute value of A in case of such sinusoidal function is given by maximum value minus minimum value divided by 2, and D is the midline that is given by maximum value plus minimum value over 2. Right, so these are the two things that you can memorize, and that's gonna solve this thing. Why did I put absolute value? Because actual sign of A actually depends on one other situation. If you have seen FRQ3 videos, I always emphasize that it depends on whether the sine function is starting from midline and whether it's going up or down, right? That's what matters. So if it is starting from midline, maybe the midline is, let's say, somewhere over here, and starting from here, that's fine. But let's say if it is going up, then a value will be positive, and this is the point I'm taking as the starting point. On the other hand, if it is going down from here and then, exactly opposite, so obviously a must be negative because it is sort of reflected about that axis, right? So we have to make a as negative, and that's why this is an absolute value. Although in this question, it doesn't really matter because all the points, all the options have a positive A. And yeah, honestly, the absolute value doesn't really change anything. So anyway, what is the maximum? Obviously, 4. Maximum and minimum points are 4 and 2. I mean, the y coordinate, just to be clear. Although in this case, x and y both are same. So even if you do a mistake here, you're still, well, in a way safe. But yeah, it's 4 minus 2 over 2. That is just 1. So I will say absolute value of a is 1. So a has two possibilities, plus minus 1. But like I said, a is just 1. So I'm going to mark this over here. And for D, I'm going to say a maximum plus minimum over 2. That's going to be 4 plus 2 over 2. That's going to be 6 over 2. So that's just 3. There's no confusion here. So for 81, I think my answer should be, what do you recommend for the best review with everything for the AP break? I think mock, right? That's what that's the only reason why I'm doing mock at this time. Um, um, uh, well, basically the important stuff. And if you're missing formulas, of course, refer the cheat sheet and try to memorize as much as possible. But try to get your hands on the mock. I think that's what is going to help you, as many marks as possible. The function is given by this. S4 is this. What is the value of S12? Okay, that's just a calculator question, isn't it? I'm given that S4 is this. So what is S4? S4 is basically when I replace T with 4, right? And then I solve for it. So S of 4 is going to be 500,000 over 1 plus 0.4 e to the kt, where k is something that I do not know and t is just 4. So I'm going to say 4t. S of 4 is 300,000. So 300,000, sorry. Yeah, 300,000 is equal to 500,000 over 1 plus 0.4 e to the 4t. These are gone. Let's cross multiply. So 3 times 1 plus, some students make the mistake of just multiplying 3 with 1. No, it should be multiplied with both. We should put a parenthesis over here. So it should be 3 plus 4 3s are 12. 1.2 e raised to 4t is equal to 5. So 1.2 e raised to 4t is equal to 2. And I think I'm going to plug that in the calculator. Okay, there's a quick tip for you here. Rather than putting as equation, I will rather put it as an expression. So in the Desmos, I'm going to type in this. If any of you guys are preparing or will be preparing for SAT, the same advice goes for that as well, that don't put as an equation, because you might get vertical lines and you will be confused. Well, anyway, it's not the right time to talk about Desmos, but yeah, just put an expression. That's the message over here. So I go on Desmos. Over here, I'm gonna type in 1.2 e to the 4x and minus 2. I'm just looking for the x-intercept here. That is 0.12. T is 0.1277 1 over here, right? That's what I have. All right, so this is my t value, but I'm not done yet because they are asking what is the value of S12. I'm sorry, what am I saying? How can that be my t value? That is my uh, k. I think I've been, yeah, that's absolutely right. I should have written 4k all this time, but I wrote 4t anyway. That doesn't really change anything except just rewriting and replacing that over here. So this is k, this is k, this is k, 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 k. So I got the value of k here. But yeah, like I said, we are not done yet. We have to figure out what is the value of S12. So S of 12 is going to be 500,000 over 1 plus 0.4 e to the kt, where k is 0.127771, and 12 means you multiply this with 12. I think I need to go to decimals once again to put this, well, gross number, of course. So let's try to plug this in and see what we have. So 500,000 divided by 1 plus e to the power of, I'm going to put a parentheses again, 0.12771 multiplied with 12 over here. So I'm getting a number of, oh, I missed a point 4, 0.4 over here. Okay, so I'm getting 175,319, 175,31917. I think should be A, right? That is the closest match over here. So I'm going to mark A as the answer. Well, all the answers are A. Last three questions. Well, that's interesting. Okay, so this is A. Let me know if you have any questions so far. All right, okay. Question number 82. Okay, 83 is the next one. So here we are given that a two-function models K and M are constructed to represent the sales of a product of a group of grocery stores. All right. And both K and M represents the sales of the product in thousands of units after T weeks where T is greater than equal to 2. K is given as a logarithmic function and M is given as a linear function. Uh, uh, so what is the first time that sales predicted by the logarithmic function will be 0.1 thousand units more than the sales predicted by the linear model? And these are predicting the sales, right? Okay. So they are saying that when will it happen that the logarithmic model, that is K, so I'm going to say the sales represented by K, will be 0.1 thousand. No need to add another thousand or multiply 1,000 to 0.1. It may not make sense because remember, these are already in thousand. So you are looking for when KT is 0.1. First time when it is zero point 0.1 more than the sales predicted by the linear model. So I think this is the equation that they are looking for. And K is 14 minus 2.885 natural log of T, or ln T, is equal to 0.1 plus, well, negative T plus 14. Again, I'm going to turn everything over or move everything on the left side so I can put this as a parentheses. So I'm going to say that this can be 14 minus 2.885 natural log of T minus 0.1 plus T minus 4. In fact, why am I even writing minus 14? Don't you think that 14 is gone from here? So that's gone. I'm just left with this one and minus this and plus this, and that should be just be equal to 0. So like I said, I will just type in this expression, making sure that whatever I answer should be T greater than equal to 2. And I'm just looking for first such number when this happens, right? I'm going to go to decimals once again, and negative 2.885 and ln x minus 0.1 and plus x over here. So I think I'm getting the first such number as 1.8, which will be rejected because, like I said, they are looking for t greater than equal to 2. And the second such number that we have is 4.32, around 4.32, right? So I'm gonna go with 4.32, and yes, fortunately, that is in the option. So 4.32 is what I'm gonna mark here, right? So 4.32, 83, correct answer is B. Okay. The function f is given by this, and using the period of f, which of the following is the number of complete cycles of the graph in the interval of 0 to 1000. All right. Now, okay, I have an idea how to figure out the period of when two sinusoidal functions are added even with different period. But since this is calc active question, I'm not going to go into that logic. I'm just going to recommend that type this in your graphing calculator, figure out what the period is, and proceed that way. So I'm just going to go here and type that in. So for example, over here I have I want to make sure that I am in the correct mode. So yeah, I am in radians. I want to type this in radians. So that's 2 sine parentheses 4x plus cosine of 2x over here. All right, weird function. But yeah, we can easily figure out what the period is now, right? I think that let's try to zoom this in. Looks like it is starting somewhere from this point. Is there a nice point here? No, all the points are, nope, none of the, oh yeah, there you go, a nice point. So let's say it starts from here because that's pi over 4, that's a nice point. So it goes all the way down here, goes up and down. And don't you think here, that's where the period is completed? Because again, it is, no, 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 not here, not here, not here. It should be a bigger loop, right? So it should be here that the period is completed. You know, if you guys agree with me, or if I'm making a mistake here, goes down, up, a small loop, big loop, and then ends here. Then again, the big loop, small loops. I think it repeats itself after this. So 5 pi over 4 to, sorry, pi over 4 to 5 pi over 4 is what this guy is covering. Pi over 4 to 5 pi over 4. So that's gonna be the period of this thing. Pi over 4 to 5 pi over 4, which is obviously 5 pi over 4 minus pi over 4, which is going to be 4 pi over 4, which is just going to be pi. So this is going to be the period. Now they are saying that how many cycles it completes in 1000 units. So I know that one cycle is being completed in pi units. So how will you find the number of cycle that is being completed in 1000 units? Obviously, you will just divide 1000, 1000, you will do 1000 over pi. If I do that, let me do this real quick. 1000 over pi. So okay, that comes out as 318.31. It means that it can complete 318 full revolutions. They are not tricking us with the options here, but if they want to, they can keep the options really close. For example, 317, 318, 319, and 320. Why I'm telling you this is because it's not, sometimes this number may come out as, let's say, 318.99. And you might think about, there's an intuition, by default, you will round this up and you might mark 319. That is not correct because 319 are not the complete revolutions or complete cycle. It just did 300, it just does 318 full and a big part of the other cycle, but still not complete. So 319 will still not be correct, right? So just a heads up when you want to do that question. Okay, any questions here? Feel free, let me know. All right, will you need to know how to manually find the period of addition of two sinusoidal function, or is it most likely to be? No, I don't think so. You need to know that manually. That is not a part of AP. That's something that I know, of course, from a different knowledge from a different course. But no, they will not expect you to know how to find the period of addition or subtraction of two um, sinusoidal functions. Yeah, it will be a calc active. That's my calculated guess. Okay. The graph the piecewise function that g be the inverse, what is the maximum value of g? I think that's a pretty straightforward question. We know that a function and the inverse of a function, the domain and range are interchanged, right? Domain and range are interchanged. They are swapped over here. Okay. So they are looking for the maximum value of g. And what is a g? G is nothing but a y value, correct? G is a y value. And y value for the g is nothing but the x value for, or x value of f, correct? Because just like I said right now, domain and range in the case of um, inverse functions are switched or swapped. So they are looking for the maximum value of y value, but I'm looking for a maximum value of x now. And what is the maximum x? Isn't that just 5? So that's going to be the maximum value of g as well, which is basically just the y coordinates. So 85 should just be c over here, right? Okay. The function f is given by this, the function g is given by this. What are the zeros of g in the interval? This is a calc active question, that's why this is not difficult. You just have to type in g and type in f here to find g, and then type everything honestly in the TID for, I mean, in the graphing calculator. So fx is sine of 2.25x plus 0.2. Obviously, just make sure that your calculator is in radian mode. Otherwise, you might be struggling with the answer. Okay, fx is subbed in here, and this is plus 0.5, correct? And what are the zeros in the interval of 0 to pi? Okay, that's where my decimals comes in. All right, I think it is, yeah, I'm unable to share, yeah, okay. All right, so I'm gonna type in sine of, I don't have to check the radian mode because by default decimals is in radian. So this is what I have, and plus 0.5. Again, guys, just type in the expression, don't worry about the equation. The first two positive roots that I'm getting are 1.54 and 2.41, and I think that should be my answer. Of course, you want to be double sure about your answering between 0 and pi. You can put curly brackets here and restrict it from 0 to pi. And that ways as well you have the same answer. But yeah, I was just looking for the first two positive answers honestly, and that gave me the answer over here. So okay, so uh, this is going to be the answer, which is 1.54 and 2.41. That should be the answer over here. Okay. We have one last question here. That is 87. Okay. A large wheel of radius 2 feet. A large wheel of radius 2 feet is rotated at a constant rate, and the figure provides a representation of the wheel in the xy plane with the direction of the rotation indicated. Fair enough. At time t equal to 0, the wheel begins to rotate. Um, at the point P on the wheel is at the start position, fair enough. At time t equal to 20 minutes to 120, rotation of the wheel would have been completed. Okay, so in a way that's they are giving us a period, although not directly, but still we can find that. And P in this is in the same position as it was at t equal to 0. A sinusoidal function is used to model the y coordinate of the function of the position as a function of time, which of the following is an appropriate model. Okay, first I want to find the period. In 20 minutes, 120 rotation. What is period? Period is the time taken, obviously, for one rotation. So if in 120 rotation, that guy takes 20, for 120 rotation, that guy takes 20 minutes. So for one rotation, how much time will it take? That's what I want, right? That's the period. So I'm going to say that 120 over 1 should be equal to 20 over t, or you could have just said that it is 20 over 120, that is 1 over 6. So that is the value of the period. Whenever we write a sinusoidal function of the form a sine b times x plus c plus d, the value of b is very important because b is nothing but 2 pi over period. And period is something that we just found, correct? So I'm going to say that b will be 2 pi over, and by the way, this is applicable for sinusoidal. So what I mean to say is for sine as well as cosine, it's equally applicable. But for tan, of course, there is a pi over here. Anyway, 2 pi over 1 over 6, because that's the period. So that's 12 pi. Honestly, that's all I want to know because that is the only option having a b value of 12 pi. But of course, I can, the amplitude is same in all of them. You can just see they are just differing in the period, and that's all what they wanted. Uh, that's all what they expected us to solve for. And yes, the value of b is 12 pi. Right, guys, this is the last question in the it's part B of this video. Part A is already there on the channel. You should see a link in the description. I'm still here for a couple of minutes. If you guys have any questions, feel free to post it in the comment section. Yeah, no, no, no. Part B alone, don't judge just by looking at Part B. I would recommend you to see Part A once. That has more questions. Calc is not active, so obviously the questions are a little more diluted. I would recommend you seeing that first and then probably make a conclusion. But yeah, Part B in itself, I'm not sure which. Is there any particular question you found it difficult, or is that more conceptually? In my opinion, I won't really mark this as difficult. Uh, but yes, overall, definitely not. If you just look at part A, I think you will get a better feel about that. Right. All right, guys, I think that's it from my side. I think I'll post this recording as well on the channel, so feel free to watch any part that you have missed or share it with your friends, in your group, etc. Whoever can be helped from this video. All right, guys, see you soon then. Bye.